How much weight can a 3D print hold? Determining the effective nozzle temperature based on print strength. Maxwell Mohr, 7th grade, Gainesville Middle. What is the effective nozzle temperature on print strength? The three-dimensional printer melts a special plastic called filament. This is a material that can be melted and rehardened when it is exposed to air. Using the motherboard, it reads a file that is inserted in the machine in the form of a USB. The printer will stack layers of filament until the model has come to life. The common nozzle temperature for printing is 200 degrees Fahrenheit. Changes in nozzle temperature could affect print strength. The nozzle melts the filament down when it reaches higher temperatures. The nozzle can be clogged if it's too hot, but if it isn't hot enough, nothing will come out. 3D prints must be monitored regularly, or they could be ruined. There are different ways a print can be ruined, but one is a very common problem this community calls a spaghetti mess. This is caused by low support on the model. This causes it to move out of place while the printer is running. My hypothesis is, if I increase the nozzle temperature, then the print will be stronger. I believe the highest temperature will produce the strongest print. I believe the lowest temperature will produce the weakest print. My materials were the Creality Ender 3 Pro 3D printer, the Creality filament spool, a wooden board from Lowe's, a circular saw, a drill, some screws, a hammer, and weights. The experiment I conducted was I collected all the materials and printed 16 cylinders in groups of 4 with different nozzle temperatures. 180 degrees, 200 degrees, 220 degrees, and 240 degrees. I created a testing model with the tools. I gathered weights and a pole to test the strength. I put weights on the pole and the pole on the testing model. I put the cylinders on the model under the pole and added weight every 10 seconds until it snapped. I recorded my results and cleaned up the mess. These are my photos and videos. You can use the links here to check out my experiment and my time-lapse. My data table shows that 180 degrees was not able to print at all. This is my graph. My control temperature was 200 degrees Fahrenheit. What does the data show? The changes in the nozzle temperature have an effect on print strength as my hypothesis predicted. However, the strongest model resulted from a print of 220 degrees instead of 240 degrees. My hypothesis was incorrect when saying 180 degrees would be the weakest print because it was never able to print at all. The weakest existing print was 240 degrees because it broke quickly without much weight. In conclusion, when choosing a temperature for my experiment, I decided to use the following temperatures: 180 degrees, 200 degrees, 220 degrees, and 240 degrees Fahrenheit. This way they would all be spaced out in increments of 20 degrees. The cylinders were not able to print at 180 degrees, so those tests were not possible to complete. This could be fixed by decreasing the range of temperatures. The data shows that 220 degrees Fahrenheit is the strongest temperature, while 240 degrees Fahrenheit is the weakest existing temperature. This information can be used to improve the strength of parts and tools made from 3D printers in the manufacturing industry.